Hey everybody, and welcome to your isotope notes. So you should have the page that says Unit 3, Topic 2, Isotopes. You should have written down your name, your class period, and your date, which is 11/2/18. Your essential question is, how do you calculate the number of protons, neutrons, and electrons in an isotope? So right here, how do you calculate the number of protons, neutrons, and electrons in an isotope? Notice this word isotope is a new word for us, so that's something that you should be looking for and paying attention. You already know protons, neutrons, and electrons from what we've talked about before. Our verb is calculate, so that means that we're going to be doing a little bit of math, we're going to be talking about numbers, and you're trying to pay attention to those. Okay, so your first box says masses of atoms. First thing I want you to write down, most of the mass comes from the protons and the neutrons. This is something we talked about before if you think back to our video from Tuesday. Not Tuesday, whatever your block date was. When we talked about how the electrons are really, really tiny, and they're kind of like if you took one hair off your head, it wouldn't really change anything about your mass, right? So I want you to know that we use atomic mass units, and we call them AMUs. I also want you to know that protons and neutrons are 1 AMU, but you don't necessarily have to write down this thing about electrons down here because we don't even count them, right? So electrons, they do not count in our mass. So this bullet right here, this one, and these two are what you should have in that box, okay? So when we're counting up our mass, each proton is 1, each neutron is 1, and your mass should always be a whole number. All right, for the atomic number, this is what I want you to know. The number of protons and electrons in an element is the atomic number. Okay, you already know that they're unique to the element. That's what you saw in your Build an Atom activity on Google Classroom. And you know we can use it to determine which element we have. So if you look here at hydrogen, hydrogen is the name. Down here is our mass. This is our average atomic mass, which we'll talk about later. And this up here is our atomic number, which tells us an atom of hydrogen is going to have 1 proton and 1 electron. All right, this is the point where you stop the video and you fill in this chart on your own using your periodic table. Okay, hopefully you stop the video. No cheating, okay? So what you should have filled in is that chlorine is the letter Cl. So if you find it on your periodic table, you notice that the letters are Cl. Its atomic number, which is the number on the top, is 17. So now you got to do a little sleuthing. You got to find Ru. And if you find it, it's right smack dab in the middle, a little bit underneath iron, right under manganese, which looks like Minnesota, right? Mn. And you find it, and it is ruthenium, which sounds like someone's grandmother's name. Probably is named after her grandmother. So, ruthenium, its atomic number is 44. So that means it has 44 protons and 44 electrons. Okay, this one. All we're given is a number, so we have to find element number 56. Found it. Barium. What do you do with dead chemists? You bury 'em. Ha 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 ha. Okay. Ag. You've probably found this one in your periodic table before. It's right above gold. And if you remember back to our crash course chemistry video, Ag is named because it's shiny gray stuff? Yeah, shiny gray stuff, just like Argentina. So this one is silver, not silver. And if you found it, you know that its atomic number is 47. Okay. Mass number. So the mass number is the number of protons plus the number of neutrons. You can write it down in words this way, or you can write it down in letters this way. It's up to you which way you want to write it. Pick one. Okay? The other thing I want you to know is, remember, most of the mass is in the nucleus, so we don't have to count the electrons. The electrons do not count. All right. We're on the very bottom of the front side of the page. Isotopes. So this is your first chance to see what an isotope is, right? It's the same element, but a different mass number. Same element, different mass. Okay, this means the protons do not change. If it's an isotope, they have the same protons. But the neutrons change because mass is protons plus neutrons. So if these don't change, these got to change, right? If you see this picture over here, we have boron 10 and we have boron 11. Both of them are boron. Both of them have 5 protons. Both of them have 5 electrons. But the thing that changes is the mass, 10. The mass is 11 here. And the reason that happens is because boron 10 has 5 neutrons and boron 11 has 6 neutrons. Those are isotopes. All right, flip your page over. So here's an example of some isotopes of carbon. Here is carbon 12. Here is carbon 13. And here's carbon 14. If you'll notice, the pink ones are staying the same. Those are your protons. The blue ones, you're getting more. Those are changing. Your green ones, those are your electrons. Those are not changing. They're 6 every time. Okay, so what does the number tell us? The number tells us the mass number. The number tells us the mass. Okay, so this number right here, the mass, the mass, the mass. These are all the mass. So on this blank, you should have written down mass. Okay. Oh, I don't think I can write in here. Great. Okay. In this box, you should put the number 6 because there are 6 protons in carbon. Every single one. So 6 here, and 6 here. Okay? That's easy. Doesn't change. The difference is with the neutrons. Let me add a text box here. Okay. So for the neutrons, I need to do some math. I need to take my mass, which for this one is carbon 12, and I need to subtract my number of protons. 12 minus 6 is 6. Okay. Now, for this one, we don't have the same mass. So 13 minus 6 is not 6, right? 13 minus 6 is 7. Next one. What's our mass? You guessed it right. Way to go. 14 minus 6. And this time we have 8. Okay? So these are isotopes. The protons are all 6. The neutrons are what change. Okay. Next, you have all this stuff already on your paper. I just wanted to point it out to you. So the mass number is protons plus neutrons. If I have 10 protons and 10 neutrons, my mass is 20. Okay? If I want to find the protons for whatever reason, I can take my mass number and subtract my number of neutrons. So 20 minus 10, and I would get my number of protons, 10. More often, you're going to want to find your neutrons, and you're going to take your mass number, given to you or not given to you, and subtract the number of protons, which is the same as the atomic number, to get the neutrons. Okay? Your electrons are the same as your protons. So anytime we have an atom, your electrons are the same as your number of protons. Okay, here's your isotope notation. Okay, so for isotope notation, what you're going to do is you're going to take the chemical symbol, right? So let's see. Say we're making isotope notation for, wow, that is not big enough. Carbon, okay? First thing we do is we put our chemical symbol right there, carbon, okay? Now, up in this top left corner, you're going to add the mass number. So say we're doing carbon 14. We're going to put 14 there, okay? Bottom left corner is going to be the chemical or the atomic number, which for carbon is always, always, always 6. So what you'll have for these isotope notations are this mass sometimes changes. This atomic number never changes. So carbons is always going to have the 6 down here in the C. This 14 is the thing that might change. All right. Here's the point where I want you to pause the video and I want you to do your best to fill in this, these guys, and try these ones. Okay, these are going to be a little bit trickier. This is going to be trickier too, but these ones for sure, protons, electrons, you should know. Okay, so pause the video now. All right, hopefully you pause the video. No cheating. Now, we are going to check our answers. So for potassium, you should have found it. It's a tricky one, but you found it. K. It has 19 protons, which means it also has 19 electrons. Not 199, 19. Okay? When you try to find the neutrons, you're going to take this mass, which is 40, and you're going to subtract the atomic number. And what you'll get is 21. Okay? When you do your isotope notation, what you're going to do is you are going to put a K, right? And up here should be your mass, which is 40. Just kidding. 40, come on now. 40, okay? That mass comes from what was given to me right over here, that 40, okay? Goodness. On the bottom, you are going to have 19. That is the atomic number. Okay, so all of your isotope notations here should have the letter, the mass, and the atomic number in that same order. Okay, nitrogen 14. If you find nitrogen, it's number 7. That means it also has 7 electrons. Don't always know how many neutrons I have, so I have to calculate. 14 minus 7 equals 7. Yay, same. So here you should have an N. Up above, you should have 14, and down here you should have 7. All right, for this one, you're only given the protons and the neutrons. So since I know the protons, I know which atomic number it is. That means it is argon. Now, if you notice, all of these have a dash and a mass. So to get the mass, I need to do 18 plus 22. Protons plus neutrons, right? When I do that, what I'm going to get is 40. Electrons, same as protons, 18. Isotope notation, AR. Up here should go 40. Down here should go 18. All right, uranium-238. Number of protons. Hopefully you found it. It's all the way at the bottom. 92. Same as electrons. Neutrons. I have to take 238 minus 92. Check my math on this one, but I'm pretty sure it's 146. Okay. Isotope notation. Put a U. Up here should go 238. Down here should go 92. Okay. Last box. Average atomic mass. It is the mass found on the periodic table. It's the average mass of all the isotopes. Those are the two things that I want you to write down. Okay. You can't use this number to calculate protons, neutrons, and electrons because it is a decimal and we don't have 0.011 of anything in an atom. Okay. So what you do then is you round it. Now, if you're given a mass, you have to use that mass, right? So if you were given carbon 14, you have to use 14. But if you're not, you take this mass and you round it to the nearest whole number. Okay. Now that you're here, you're at your summary part. Okay, so I want you to write your summary. 3 sentences. If you're having trouble figuring out what to say, put down the most important part. Why is this important in science? And what did you already know? Okay, so again, most important part. Why is this important in science? And what did you already know? Once you're finished with your summary, you should go to Google Classroom and open up the thing that says Isotope Practice, and that's what you're going to do next. You're going to be doing some calculations. So you might want a piece of scratch paper. You might want to use your phone as a calculator. I'm giving you permission because I'm not going to put out calculators today. So go ahead and get done what you need to get done. Okay. Email me with any questions, chumes@isd271.org. I hope you're having a great day. See you soon. See you Monday.